RFLOW, a time-of-flight radio frequency interface for passive, non-line of sight, fine interaction, and multi-object tracking. We show a radio frequency-based system for fine, passive, non-line of sight interactions. We also show how this system can be used for interaction using chipless ultrapassive echo patterns with time-coded reflections. These interactions are important for cases where camera cannot be used, including non-line of sight, through wall, outdoors, and privacy situations. We call this system RFLOW. Our system uses ultra-wideband time-of-flight and enhanced trajectory detection to capture hand motion in 3D. We transmit a pulse of radio frequency into space and measure the time of flight traveled between the transmitter and a multiplexed receiver array. We then localize reflections from objects in the scene. We utilize simple scene understanding to separate the reflections of the body from that of the hands. In addition, we use simple, powerless, printed time-coded tags to mark and better track objects and interactions. Our system has four main advantages over other hand tracking technologies, including no instrumentation, privacy, the ability to work in broad daylight, and identifiability. We demonstrate this idea using an ultra-wideband time-of-flight transceiver multiplexed between four receiver antennas. The system transmits a pulse and then uses a continuous time binary value to find the time of flight of all reflections in CMOS. Normally, localization of an active source will only require the intersection of four ellipses generated by range measurements. However, with multiple targets, aliasing leads to ghost locations. We exploit the close-range geometry of our setup to separate hands from bodies by selecting the first major reflection and exploiting the fact that hands in motion move faster than bodies. We demonstrate this by tracking a waving hand in 3D. We implement echo patterns using an antenna and a delay line. Each tag is coded by the delay line. We also miniaturize these tags onto printed circuit boards. The system works in two modes, natural mode and echo mode. In natural mode, the trajectory of an uninstrumented user's hand is tracked in 3D space. This tracking also works for echo patterns. In echo mode, multiple echo patterns are identified. The pattern works as a wireless, powerless button that can be placed in space and interacted with. Instead of interaction design, our goal is to enable a refined 3D radio frequency interface which works beyond the line of sight. We show the technique in the context of two simple applications: a radio frequency smart mirror for uninstrumented interaction without a camera to preserve privacy, and a set of wireless powerless buttons. Although our focus is on enabling the technology and not on novel interaction design, we hope our work will inspire new interactions in more places in combination with optical, magnetic, and sonar sensing.